Alright everyone, I want to do a quick video before I pick up my kids actually. It's going to be a bit out of order from the other videos. I want to talk about databases, just very briefly, because A, it's not a database class, and B, because, well, I don't think I'm the person best qualified to talk about them. But I want to talk about relational databases at first. This would be normal databases like SQL, Access, that sort of thing. Now, SQL and MySQL and all of these other databases have some things that are very much in common with each other. They have particular things that they're always, trying to optimize. One of them is that they're trying to remove data duplication and versioning. Unlike me and my Google Drive and my various folders and stuff like that, unlike me and my basement and the stuff I store in my basement, I'm trying to actively go out of my way to avoid duplicating data, duplicating things, storing everything that I possibly come across. I'm trying to minimize the amount of stuff that's being stored while making it sort of bulletproof and making sure that I don't lose data. So I want things, we could say ACID transactions is the normal term is used, and that's you want atomic operations, as in when I do a query, I don't stop halfway through the query and then do a remove at the exact same time. I'm not multi-threading with my removing things from my database, adding things to my database, changing things to my database, getting individual elements. It's an atomic operation. So when I do a query, it comes back and that's what I get. I don't have to worry about timing of various things. I get a consistent answer. I pose that query 40 times. I get the same answer 40 times unless something changed unless I manually change something about my database. It's not, yeah, it's close enough, right? No, it's a consistent answer. It has to be durable, and I'm going to think about what isolation is. Durability would be you don't lose data. It's robust. It can handle things. And isolation, I think you should be able to isolate individual parts of your query or move things around. The big thing for me is you're trying to minimize the amount of data duplication. So you don't just store multiple instances of the same thing because it's going to go out of sync. If I have my name and address in the database 4 different places, if when I move, like I do all the time, it turns out, I would have to update it 4 different places. I'm going to forget one of them, right? I'm going to forget to post the links to the assignments for the same thing, right? Anything with multiple different versions of stuff, there's a very good chance that something gets out of sync or goes out of date. You also have really good access control and data security with one of these systems. You know what you're getting. These are well-studied systems. And there's a very precise language for retrieving information. It's not kind of. Everybody is using the same language, and there are distinct ways of querying the database, a particular process. So even if the query is not accurate, there's a precise way of actually getting something. So even if I'm giving the wrong query and I'm not getting the right information, there's a way to do that wrong query, right? It doesn't mean I get the right answer. I could have made the query wrong, but it's not that I have an order of operations issue. When we look at access, there's actually an order of operations issue. If I try and write too many queries at one time, I don't know what the result is. With most databases and using SQL, it means it's very, very precise of exactly what kind of records I'm going to be returning. So let's talk about what the heck SQL actually is, or most of these relational databases are. They are a bunch of tables of data. So I can have something like products, and I can look at, let's see if I can do the database tools and relationships. There we go. And let's also, maybe I can zoom out on this thing. So I have my products, which are connected to line items. This is a particular database of tech equipment bought at a computer store. Why? Because I got it from another course. Anyways, so I have an order from the store. I have line items. This is like, I bought this hard drive. I bought this, power cord. I bought, this mouse. Like the items per line in an order. Each line item is its own record. I have individual records for each individual line item. The orders themselves have a bunch of line items in them. So I have a particular order, I have who made the order and the order date, but the line items themselves point to what order they're part of, so that I can separate these things so I'm not reproducing data. The line items themselves are connected to the products. So any given product, it might be in multiple line items, so 1 to infinite. So any given product can be in a line item, so I have different line items with that same product. But I stored one time the product ID, then the unique identifier, the key for how to find this product right here. This key literally shows a key in this case, but the key for that table is uses the product ID. And so if I have a line item, I could find what the product is and all the information about the product, but I don't need to store how many units are in stock, what the price of the item is, what the depth, the weight, and the height is. I just have an ID for what the product is, and I don't have to reproduce that. I don't have to write down for every line item what information about that product. Similarly, for every single order, I just have the for every single line item, I just have the ID for the order, and I can look up the order and the information about the order. Or more importantly, I can look up with a line item, I can figure out what the order it's involved with, who ordered it, and where they're located. Notice even zip codes. I don't want that. This is what a postal code is in America, in case you didn't know. I have the address for the person, I have the first name and the last name, the contact information, the phone number, but I do not need to write the city and the state multiple times. Why? Because if I have Grand Rapids, Michigan, I don't want to have to write all of those text characters. I have it stored one place in my database, and the zip code is the lookup for this thing. It makes my life a whole lot easier. All I need to do is store is that one number. That one number then allows me to find the city and the state based on the zip code. I'm trying to avoid duplicating things, so I break this out, and what I have is tables of information, tables that look like this, where I have each one of these things as a row, and I have a whole bunch of different columns in here, which are the attributes for those rows. The whole thing makes up a table, and I string together these tables to allow me to store things in an efficient manner. So I don't have to, I'm not replicating data. I don't store the city and the state for every single line item. For every single line item, I would need to store the city, the state, the person's name, the this, that, right? I want to store it once. That's what a table allows. This is what a relational database allows me to do. I store the city and the state once, not 50 times, once. And so I can scale with these things. That's the nicety of a relational database. So I did a bunch of these different queries, and I can give you access to this one. I was going to be egocentric, and I'm going to look at this particular query here. So I want to see what the heck the query was. So let's see, design view. Here is what I have done. I have done a filter. This is what Access will do. I am doing a filter. I have the zip code information, and I want to filter out everything that is not in Massachusetts, MA for Massachusetts. Why? Because I'm egocentric, and I just left Boston. I can even look at what this thing looks like. I should be able to look at what this thing looks like, at least with the SQL view. Here is what this query looks like. I'm going to select this table, all the attributes for that particular table. From this zip codes table, I'm going to get the attributes for zip code, the city, the state, where the state is Massachusetts. There is no ambiguity in that statement. It is a very precise statement. That's what SQL looks like. Let's get back to the design view. Okay. So from there, what I can do is I can go make another query, and I save this. I can make another query, and I could say, let's go back to my design view for this one. What I can do is I can take this query, take the context, hook them together by drawing a line between the zip code and the zip code. So when I use a zip code, it goes to this zip code. I can hook them up to say this is how these two things are related. So when you want to search through zip codes, you can find this is the primary key for the for this particular table, and I can find the city and the state based on a zip code. Okay, and this thing is saying make sure in my query I'm going to have the contact ID, the first name, the last name, the address, the zip code, the city, and the state that all match. Now you'd say, what's the difference between what I had before? Well, I've already filtered out any given zip code that does not have Massachusetts in it. So the only commonalities, this is called an inner join, the intersection between these two tables, this table here and this table here, the only things in common are zip codes with Massachusetts in them. Therefore, anything that does not have a Massachusetts zip code, any of the contacts that do not have a Massachusetts zip code are being removed. I'm getting the intersection of these two sets of data. The only thing in common is this were zip codes in Massachusetts. So if I actually look at this query, hopefully I have, that's the old one. Let's just run it. Boom. I get Ronald McWilliams, Michael Lipton, Giancarlo Piano, and Scott Hoyler, and they're all in Massachusetts. All different cities in Massachusetts, but they're all in Massachusetts. There's actually no duplication. There's nobody that is in the same house or anything like that. I can go one step further. Let's look at what I was trying to do originally was I wanted to find out all the different items bought by people in Massachusetts. At least I think that's what I'm doing here. Yeah, all the different items bought by someone in Massachusetts. And what I have to end up doing is combining those data, the query from the last query. Here is the last query hooked up to the orders because I have the order number has a contact ID. The contact ID matches those two up. So this connects to this. So the intersection with these tables and this table, the only thing in common is people that live in Massachusetts, because only people that live in Massachusetts are in this table, and therefore the only orders that I'm going to show up are people from Massachusetts orders. And so I have a product name, the order ID, the quantity, the address, and I can do all sorts of things to manipulate my data. But it's this art form of recombining or merging, taking data spread out over multiple tables and joining them together to get the information that I'm looking for. That is what a relational database does. It is joining and manipulation of tables. Okay. That's what I wanted to go over with. Now, that seems like a very crash course. It's because it is. I'm not going to go into the nitty-gritty details of what this query looks like. So here's my SQL view. It looks like this is what a SQL query looks like for that same thing. Right? Here are these fields from this join of these particular things. I'm using an inner join of these line items, and I'm doing this, that, and the other thing. The important thing to note about this is that this is a well-established protocol. And so when we come back later on, let's see where this thing is. When we get back to it next time, we're going to look at non-relational databases or NoSQL databases. And I don't know a lot about these, but I'll say what I know about them. But the key differences between them, why one works in some cases better than in other cases. And from there, how it relates to the human factors associated with using them. So rather than the database theory behind it, what are the pros and cons of each of these things from someone that's actually using and inputting data into these systems? Okay, so with that, I'm going to take my leave of you, and I'll come back later with more talking about information retrieval. Thanks, everyone.